What I want to tell you in the rest of this talk is that this little cycle between ideation and user testing will also let you bridge potentially what is one of the most significant gaps in the design of health interventions, which is how to go between theory and a concrete implementation of a particular intervention feature. And so to see that, stepping back, sort of, most of us have this kind of a mental model of what development of mobile health interventions is like, right? You have some theory that allow or set of theories that will guide what kind of components you want to have into your intervention. You have some understanding of who the target users are and what the context is. You mix all of that knowledge in, you shake it up, and you build this awesome health intervention that has certain health outcomes that you're trying to achieve, right? And in particular, sort of a lot of what we do really has to do with selecting the different kinds of mechanisms that you think will push on the behaviors you're trying to affect through your technology, and then really implementing those as intervention components or intervention features. You can go to your favorite theory for this, or you can take something like Susan Mickey's taxonomy of behavior change techniques and sort of use things like self-monitoring and planning, goal setting as components of what your system is going to do. The problem, though, is that for any one of those theoretical concepts, or any of those behavior change techniques, there are many, many ways you can implement it. At the level, once you actually are at the concrete level of a system, there are many different ways you can do that. So going back to our example of food tracking, here's some examples of how you can self-monitor food, right? On the left here, you have, in this particular case, it's a screenshot out of the Jawbone app. But basically, you have what is a database-driven solution where you look up the foods that you're eating in a database, and then it sort of goes into your food log. In the middle here is a system developed by Adrian Andrew and James Fogarty at UW, which does food tracking in terms of these different kinds of food groups like whole grains and fruit and fruit juices and so on. And you basically you log how many servings of each one of those food groups you do by hitting that +1 button next to each one. In the top right corner is a system called FewTouch by Eric Hard from Norway, which was designed to help patients with diabetes track their food intake. And all there is to it are these big 6 buttons, right? Where for everything you eat, you classify it either it was a high carb snack, a low carb snack, a high carb meal, a low carb meal, and then a high carb drink or a low carb drink, right? So you just press one button to say what you've eaten. And then in the bottom right, you have an example of using your camera to take a picture, right? And then there's this little slider, which is something which is very similar to what Frank Bentley and his collaborators did in the mobile health mashup system, where basically you just say how much you eat it, and you can by doing a single slide, right? All of those, as different as they are implementations of self-monitoring of food intake, right? Very, very different solutions. And you need some way of figuring out which, and there are many others that you could use, right? Which one to go with, right? So really the challenge here is to figure out how to develop an optimized version of a particular intervention component that you need in your system. So that you have a robust solution that serves that particular function within the system well. And so at least those of you from behavioral sciences, when you hear the notion of optimization, you're probably thinking about Linda Collins and the use of factorial experiments to select among intervention components, right? So Linda has done some really wonderful work with her multi-phase optimization strategy to really advance this notion that we can build systems that contain only sort of components that work well, right? That actually are effective, by doing fractional factorial designs where you try different combinations of features that you're considering implementing in the system, and then that allows you to make a selection of a subset that work well, right? And that's definitely where a lot of this work that I'll be talking about is going. But if you sort of think about what's necessary for that kind of optimization, you first need this first step to generate, right? You need something that you can push into the optimization pipeline. And so you need intervention components, that you can test, and you need decision rules, especially in the context of mobile health. You need to know when particular intervention component is going to be used, right? So you need to first create those, and then you need techniques to optimize those components, uh, decision rules, and then system as a whole. And so the question is, how do you actually develop these individual components? Well, as Julian mentioned, you create a whole bunch of alternatives, and you think about them systematically, you test them, and then you choose among them. And then those things that you think have the most legs, those are the ones that get pushed into the optimization pipeline. So let's talk a little bit about this generate phase, because I think that's actually one of the areas that is often the hardest to bridge, because we really, at least in behavioral science, think at this conceptual level, and going from that to the actual intervention feature is tricky, right? So let's go back to our example of food tracking. Often, some of the features that you need have a lot of history, right? People can build many systems that include food tracking components, and so sometimes the kind of list that you can start with already sort of has examples of things that have been used before, and for which you might have some efficacy data, as well as some of the things that you might want to that you've come up with for the first time. But really, the idea here is again, as Julian was mentioning, to generate a whole lot of alternatives. In this particular case, I'm giving you screenshots of ready-made systems, but you can actually just sketch these out, or even write them out in a way that will describe what this particular version of the component is supposed to do and how it's going to do it. And the more of these you generate, and the quicker you generate it, the better, right? So again, for some of them, you might actually have a lot of background literature and background knowledge that you can draw on to create that initial set. For other things, and what this allows you to do is not only to come up with a whole bunch of alternatives, but also to start thinking about what makes those alternatives different from each other. So what is the space on which they differ? And in this particular case, one of the ways that these things that I have on the screen previously differ is in how granularly they track food, right? Are they tracking exact calories? Are they tracking sort of coarser amounts? Are they tracking particular food groups, right? And are they just tracking the helpfulness ratings? What is it exactly that you're tracking? That's one of the many dimensions along which these kinds of components differ, right? Another dimension along which they differ is how much time it takes to use it, right? For any of you who've used a database-driven system, you know that it can take quite a long time to log even a single meal, especially if it's not a packaged food, right? If you've actually created something, it's a pain in the butt to do that, right? It's a very different experience than pressing one button on that system in the top right, or just sliding the slider that's using the bottom right? So that's another dimension of which a lot of this stuff differs. But other times, all you're starting with is a hunch, right? So there might be something that you think could potentially be an effective way to change behavior, and you have a hunch about what that is without really knowing exactly what construct you're talking about. So I'll give you an example that comes out of the work from Elizabeth Korinek, who is currently postdoc at Arizona State, working with Eric Heckler. She was working on one of Eric's walking studies, and one of the things that she saw is that people really like variable daily samples that they were given during the study, right? And so she thought, oh, maybe there's something about this variability that could be an effective way of changing the data, right? And so this is a hunch, right? It's not well defined yet as a construct, certainly not of a construct of a kind that Susan Mickey would put into taxonomy, right? But it's interesting. It's promising. So the question is also, how do you go from that kind of hunch to a component that you can have, right? And again, ideation is how you start with here. So what Elizabeth did is she brainstormed as many versions of variability of goals that she could come up with, right? So here are 15 things she came up with, right? So you can do more high goals factors. You can let users choose a goal, right? You can have sort of graded increasing goals. You can allow a person to sort of take a day without a goal. All of these different things are actually different ways that a particular goal can be made more variable from day to day, right? So again, you sort of start with a whole bunch of different versions of this particular hunch. And then you can group them, right? So what Elizabeth did next is that, okay, these things actually fall into a few different buckets, right? So you have what is called epic goals, which are just having some goal during the week that is really high, right? Providing users with some user choice, right? Potentially playing with the amplitude of the goals and then providing some red things, right? So all of these fall into several buckets, some of which might be more interesting and more potentially feasible than others. Right? So you're starting now as you start with this initial large group and then doing affinity diagramming or a technique like that to group them, you're starting to get a better understanding of what that hunch actually is about, right? What is the concept you're trying to get at? And now you actually have something that you can start choosing about, right? And this is which gets us to the selection phase, right? So whenever you have a set of alternatives that you start with, you need some way of figuring out which alternative you go with. And there are basically two ways of doing that. One is to go back to your user research and to your understanding of constraints and to try to figure out sort of what are the constraints that you're dealing with and which of the alternatives, how the alternatives fit on those constraints. And I love this quote from Bill Buxton, who is an interaction designer. He's currently at Microsoft at the University of Toronto. But he says that basically all design is compromise. This goes to the fact that there's no perfect design, right? You're going to be making trade-offs, and even within the same alternatives for the same feature, different versions of that feature will have different attractive and unattractive features, right? And basically, whichever one you choose will end up being a compromise. The idea is to come up with a compromise that is that has the most of the stuff that you want and the least of the stuff that you don't, as much as that is possible, right? And the way to do that is by thinking carefully about your constraints. So in the case of our food tracking, here are some potential constraints, right? You might want for the system to be used long term, right? And you might also want it to not be require a lot of nutritional knowledge to you. There's a question of the learning curve, how long it takes to learn to use the system, and then you might want a certain kinds of data, right? That depending on what else you're trying to do with the system as a whole, that might be a constraint in the system. That allows you to now start picking things, right? So we know for a fact from all the work that's been done before that people have a really hard time using a database system long term. It's just too much work, right? So if that is a really important constraint, right? If you want someone to do food tracking for a year, then a database-based system is often not the optimal solution just because it's way too much trouble to use long term, right? If you're targeting a population where you don't have a lot of deep nutritional knowledge, then a system like Cons that really requires people to understand what the ingredients are within the food that they're eating might not be a good option either, right? So the constraints and being explicit about what the constraints are can help you make choices among different kinds of and different options for what you're considering. And those constraints can come from different places, right? So behavioral theory will push some constraints. Your understanding of the user population will come with certain set of constraints. Usability will have constraints as well. So how much effort something is, how much value people are getting out of it, as well as the requirements of the overall system. So if you need certain kinds of data, if you're trying to provide feedback that uses certain kinds of graphs, then you can only use the self-monitoring components that provide you with the data that you can graph in such a way, right? That's a constraint on the system, and as well as what has been known from previous studies about what things work. But sometimes, really, what you care about is picking something that is most likely to actually have an effect, right? And so knowing, and especially if you're dealing with a situation where you're trying to implement a feature that's based on a hunch, right? You might not have upfront a really good idea which one of these things will actually work, right? And in those cases, there's really no substitute for running a study, right? And the question becomes, how can we run studies that are quick and dirty and that give you just the kind of information that you need to be able to make that kind of initial product, right? So what we're not talking about here is sort of robust efficacy evaluation. We're talking about evaluations that are part of the design process. that are really used to help you make decisions about how to design a system, right? So you want to make choices, right? And sometimes is this likely to work? Might be one of the criteria that you need to make that choice, right? And there are going to be two main things that you will need for this kind of study, and now we can get to those in a second. Mostly, it has to do with being able to specify your proximal outcomes really clearly, and then having some ways of actually developing something that can be tested by real people in the real world as quickly and as cheaply as possible. Right? And then there are different kinds of methods that can be used to do this, including single case studies, like randomized trials, and as well as if you have access to a large population, you can actually do some very quick and dirty RGPs as well. So this is what Elizabeth ended up doing with her global variability study, right? So she selected three different kinds of components that she thought were interesting and that might have some hope of changing people's walking behavior. So epic goals, user choice goals, and high amplitude goals. And then she recruited 10 people who already had Fitbit, right? So who actively use Fitbit because those people already, she could get baseline data from them just by the fact that they use these trackers already. And she used the Latin square N1 design where she basically had each one of them in a balanced fashion used for a week at a time, one of those three different kinds of goal variability scenarios, as well as the sort of control condition of what the study they were already doing in the previous studies. And she looked at sort of average daily step count for a particular condition as the output, right? Very small n, but enough paired with interviews and people's sort of experience of using these kinds of systems to get some sense of which of these might actually be something that you want to invest more energy and more resources. Again, right? It's helping a selection. It's helping her decide what to use in the next step, not necessarily a robust evidence base on how well a particular type of goal variability is working. And again, in order to do this, you need a clear proximal outcome and a way to prototype these systems quickly, right? So let's talk about proximal outcomes because this is really a core concept for doing quick and dirty evaluations in mHealth, right? And you should think about proximal outcomes as the most direct effect that a particular component of your system is intended to have, right? So we're not talking about distal health outcomes. We're not talking about mortality, whether changing habits long term. We're not talking about the incidence of cardiovascular events. We're talking about the most direct thing that a particular component is supposed to do. So if you have, for example, a little system that reminds people to disrupt their sedentary behavior, right? And it pops up a little reminder on your screen when you've been sitting too long to get up. The proximal outcome for this is just whether you get up, right? When the reminder came up, whether the person actually got up or not. That's your proximal outcome for this. Those proximal outcomes are you can sort of think of them as mediators of the distal outcomes that you care about, right? So they can be sometimes the micro version of the distal outcome that you care about. So if you have a walking intervention where your goal is to create a habit of walking, let's say 10,000 steps a day, for a particular sort of message that you send to someone asking to take a walk, a proximal outcome might be just how many steps they take in a period of time after that message is sent, right? So in that case, it's a micro version of that. But it doesn't have to be so, right? So you can think about something like a mobile health system that's supporting people who are trying to stay sober, right? And one of the things we know from the literature is that the social support from sobriety supporting friends is really important. So you might have a component within that system that just encourages people to engage in communication with sobriety supporting friends. For that kind of component, your proximal outcome might be just how many times they reached out to sobriety supporting friends every day, right? It's a mediator, it's sort of a mechanism through which sobriety will be achieved long term. But really, what you care about is for that component is are they reaching out to sobriety supporting friends or not, right? And then different intervention components within the same intervention can have different proximal outcomes, right? So some of them will be targeting, in this particular case, cravings, like if we stick with this example of substance use, Others will be targeting social support, and some of them might actually be targeting engagement. Just are people using the system? So again, there are different kinds of them. Health behavior of interest might be one type of proximal outcome. A mechanism through which you think that the change is accomplished, it might be another one. But then, really, for designing compelling, useful systems, you should really also think about components that have usability and so the use of the system as one of the outcomes. So you can think about engagement. You can think about whether there is someone like an intervention component that was just sent to them as potential proximal outcomes that you would be testing as well. And then you also need some way of actually testing these things, right? And so you need a way to prototype. So the kind of prototyping that Jimmy was talking about is really what we do very early on for the features where you can sort of get a good sense of how they're going to be working through catching. But if you're interested in having this kind of preliminary efficacy data that to make decisions about based on is something even likely to work, right? You might actually have to build something, right? But again, the idea is to build it very quickly and cheaply, so you can run studies as quickly as possible, and then move on to doing the next step. And again, the criteria here is quick, cheap, minimal representation of the constraint that you're trying to test. And the good news is that there are many off-the-shelf products that you can use to do. So you can actually do this kind of testing without doing a single line of coding. And so I want to give you a few examples of how some of this can be done. And so one of the systems, and this is the one that Elizabeth used for her variability study, is a system called bulk SMS. It's basically a way to send people text messages from the web. You upload a spreadsheet with phone numbers and what needs to be sent, right? And the thing you just send it to people on the schedule that you created, right? So as long as you have the phone numbers of people that you're trying to reach, and you know what you're supposed to be sending them, you can just upload the spreadsheet and people send text messages. And in Elizabeth's case, basically every evening she would upload the spreadsheet that had the goals for the next day, and the system would just automatically send it in the following morning, right? No programming at all. Easy enough to do manually for 10 people, right? You probably don't want to be doing this for 2,000 people, but for a dozen people or a couple dozen people, this is a perfectly feasible way to go. And you can just do it with any kind of sort of textual context where having basically a push intervention makes sense. Something like bulk SMS might be a feasible way to have that quickly. Another one is a system called proximal. This was developed by Bob Evans and Google, originally as a toolkit for ecological monetary assessment, so for doing form-based questionnaires, but it's increasingly being developed into a framework for doing just-in-time adaptive improvement. So it's able to trigger questionnaires off of sensor data or off of time, and you can now even do some simple interventions just in simple JavaScript to enable not just data collection but actually intervention tools. But also, like with bulk SMS, anything that you can turn into telecommunication can then be delivered using Paco both on Android and iPhone relatively easily with no program and using sensor data. So, and then finally, I don't know how many of you know if how many of you have come across this? Yeah. So this is a really nice little web-based system that allows you to use web-based applications that have public APIs and string them together into recipes, right? So you can basically create anything that has a way of publicly exposing data on the web, Gmail, Yelp, and things like that. Can all be combined to create a set of behaviors that will of data propagating to the system across those different applications to do. And it works both with iOS and Android. It can access some of your phone-based data, and it can use data in these other web-based resources that might be relevant for intervention in a way that allows you to test ideas relatively early on. And then there are other things as well. I mean, there are many what you get tools for building websites that you can use to develop web-based applications. But the larger point here is that really off-the-shelf products can often get you close enough to what you're trying to develop, so you can get some preliminary information about those ideas without actually building them up, right? So again, this is preliminary data to support design process, right? It's not robust efficacy data, but as long as you can take the ideas that you're considering and convert them into using one of these tools or multiple of these tools into a test for that concept, you can get some early information about how this is going to work for your population and whether it's worth investing more resources. And then once you make those selections, then you can go into the optimization phase and try to actually get something that will work really well. So things to consider in terms of selection, right? Might not be one clear answer, right? So there might be multiple versions of a concept that you're considering using as an intervention component that have different trade-offs but are pretty close. Yeah, there's no magic bullet for that, right? So you basically need to make a decision at some point, but and then often running some kind of a quick and dirty study will actually be the kind of information that can help you make those decisions. Empirical data again can really nicely supplement the information you have about constraints from your formative work to make these decisions. And any kind of a decision you make on one intervention component, and I think you will see this in your projects this week, can often have effects on the system as a whole. And so the process ends up being really iterative because you make one decision, it has effects on other things. So you make a decision about a food tracking feature. Now that's really puts constraints on what kind of feedback you're able to give people. You fix that problem with creating new feedback mechanisms, but that might actually now affect what else how that data can be shared and so on. So there's these downstream effects that you have to constantly track in terms of how else is the rest of the system being affected by the decisions you're making, and then go through that cycle repeatedly until you have something that is coherent and works well together. And it's only then that you actually, when you have a set of components that you think are promising, that it's actually then we're going into the optimization phase and trying to refine those components, trying to refine the decision rules based on which they run. And there are a number of methodologic experimental designs that can be used for that Billy will be talking about in her talk, right? So, but really, what I want you to take away from this is that really that you can use both empirical studies and this design process of creating many alternatives and then narrowing them down to come up with initial takes of the intervention components that you want to improve. And that part is really necessary for any of the other wonderful work that we've been doing in the optimization area to make sense of these methods, right? And in many ways, what makes this somewhat different is that early optimization work was done with communication. They were done with messaging, right? But now we have user interfaces that need to be developed first before, and so we really need these design processes to be able to create those user interfaces that can be further optimized. All right, so just to summarize. So the design ends up being a wicked problem in the sense that it is highly contextually dependent and that it is unique and it has better and worse solutions, but not sort of the right solution. And the design process, and especially this loop between creating many alternatives, finding ways of making selection of those among those alternatives, and then refining the selected set can help you give you an approach to deal with the messiness of the design problems, and that really the generate phase of this process is really important, and that the design process gives you probably the best tool you have for creating robust early versions of the components that then can be further optimized using the implementation methods from the development. Thank you.